Hey everyone, I'm Huda Mahdi and I'm an ACN tutor. I teach games programming and business here, and today I'll show an example of how you can jump right into games development and start coding your own AI behavior. So we'll be using the Unity game engine, and just like we do in class, and we'll be coding in a programming language called C#, which is a common language both in the games industry and as well as other industries. So without further ado, let's start Unity. So when you download Unity, you'll get access to Unity Hub, which basically is an app that gathers everything Unity in one place. You have, for instance, your projects here. Your Unity projects will be listed here. You can add more if they're not there or create a new Unity project. You also have the Learn tab, which is very handy because it's listing all tutorials that Unity has developed and is free to use and modify. I think you did this one with Lucy a couple of weeks ago, and today we'll be using another one called Unity Playground. So I have already downloaded it, but if you click on it, it will start downloading. So this is what you'll see when you open the project for the first time. You'll see here the hierarchy view, where all the game objects are listed in the game. The scene view here is basically your editor. This is where the action happens. This is where you start editing things, right? And then it's a 3D editor, but when you press on this button, it will turn into a 2D view. This game view here is essentially what you see in the game, the actual game. This is where you preview it. We have also the inspector view here. And this inspector view is dynamic in the sense that it changes depending on the game object you click on. So whatever you click on, it will inspect it and show you more information about it. It will show you components, basically the attributes or scripts that are there or anything that the game object is using. And then you can modify it from here. So in this scene, we have main camera and the light. So as you see in the inspector, it changes depending on where I click. This is what the main camera has. It has a transform. All game objects have a transform, both 2D and 3D. And basically what a transform is, it's a component that will tell you the position and the rotation and scale of this game object. And then some other things. So in this case, we have a camera component here and also an audio listener. Basically, we're telling this scene that this camera, this is where our ears are. This is where we listen to sound. And the directional light is a game object. So it also has a transform. And then it has another component, which is light related. Down here, we have project view. Project view is basically where all your project files are. So here is under assets. This is where you'll find all your scripts. You'll find all your art assets, audio, anything that you have put in the project files. And these project files are from the Unity Playground project that we downloaded. So you'll not see these every single time. And here in the examples, you'll see 6 different examples. So each one of them is a different and independent game or game prototype. The one we'll be using today is called Defender. So let me open it up so you see what it's like. So Defender is about this turret defending, I guess, Earth from meteors falling down. And the idea is that you basically shoot down the meteors before they hit the ground and explode. So we hit the play button. Now we can play. You have health. So, and you shoot with space. And you can turn the turret with A and W, so left and right. And basically, so you score every time you shoot down a meteor. This turret is not very easy to control. So I have found myself needing some help. And that's where our robot is coming in. So basically right now, it has no role whatsoever except from making me even more nervous and panicky about the situation, it can be much more helpful than this. Yes, yeah. Every time a meteor falls down, it will take 1 point from my health. This robot here can do much more than this, and that's what we'll be working on. So first things first, before starting, some stuff that we need to do. Here we have the resolution. It's usually set to free aspect, which basically means whatever you can fit in the screen. And this is really bad because it won't give you the actual representation of the game. So if you place an object, you're not guaranteed that it will be there once you have exported it into a game. So what we want to do right away is to click here and change it to standalone, so we have something more fixed. Now, no matter how small or how big, we know exactly the resolution and what will fit and what will not. The same thing here on the scene view. Usually it's in 3D space, this editor. But since we're working on a 2D game project, we want to click on the 2D here to the 2D button and change it into 2D scene view or 2D editor. And then we can only control it in X and Y, and the Z is locked. All right. Now, what we want to do is to make this robot a bit more helpful, right? Right now it's patrolling just next to the turret, which is not helpful at all. We want it to patrol alongside the whole screen in X-axis. It's not going to fly anywhere, not yet at least. And we want it to shoot down any meteor that is above it. So that's the least it can do. So let's see how we can achieve this. So the first thing we want to do is to inspect the robot. We can find it under decorations. If you click on it once, the inspector will change and will show you more information about the robot. So it has a transform like any other game object. It will tell us the position, rotation scale. It has a sprite renderer, basically renders the art. It has a rigid body, which is something very important. It's for physics. It will tell us, or it will tell the engine that this is an object that will be moving. It's flexible. It's not a static object. So the physics engine will start calculating it in. And it has a patrol component here. This is actually just a script. You can write this script once you get more hang of decoding. But essentially what it does is it's using the original point, the original position of the robot as one point, as a starting point, and then puts another point a bit further away from it, approximately here, and then tells the robot to go back and forth between these 2 points, the original point and the other point. These types of points are called waypoints. And essentially what they are is basically just positions on the way. This is how you make, this is a very simple way of making an AI bot or whatever NPC move around, is by putting waypoints. So that's one way, and a very simple way. What we want to do is we want to make it patrol a bit further out in the screen. So basically I want to, if you just hover here on the scene, click F, it will go, it will zoom in on whatever has been marked in the hierarchy, right? So I want this robot to go from this side of the screen to the other side of the screen. And what I do is I take the original position, put it here, approximately here. And this is the other waypoint. You can drag it around. You can see here that the X is changing when I drag it. And I want to put it all the way, let's see, all the way here on the other side of the screen, right? So this line here is telling us the resolution. This tells us where the screen is, basically what the screen is showing. So we have now one original point here at the beginning, and the other one is supposedly here. Let's see if this actually works. So if you press play, let's make this bigger. Let's see if it, yeah, it seems to be. Will it go back and forth? I'm really bad at this game. You see why I need so much help? Yeah, it seems to be working. So awesome. That's is done. All right, so now that we're done with patrolling, we want this robot to start detecting meteors, right? So the way this can be achieved is there are different ways. The way we will be using is a more visual one. We will be basically creating a box, an invisible box that is going to act as a trigger. So it's not a box, a physical box that meteors will collide with and maybe, you know, move away. It will just be a trigger. And as soon as this meteor touches it, it will send an alarm to the robot or an alert. Hey, there's a meteor here. So firstly, before doing that, I want us to, because the robot is under decorations, it's no longer going to be a decoration. I want to just take this robot, drag and drop it anywhere outside here. So it's outside this hierarchy. It will be easier to work with it. And now, so how we create this trigger is we create an empty game object here. We can call it trigger as such. And right now it's empty. It only has a transform. It only has position, rotation, scale. And what we can do is we write, so write box, this will come up, box collider and box collider 2D. We want the 2D one because we're working on a 2D game. Now, if we mark, that's where it is. Yeah, if you click on trigger here, you will find your invisible box trigger here. What we want to do is we want to put it above the robot, right? So if we move away the robot, where is it? Oh, there it is. So if we move the trigger to the robot, so it becomes on top of it. This is pretty much what we need, right? Except that we don't want it to trigger things this close. We want it to trigger all the way up, you know, in the whole screen. So we want to scale this trigger box. Here is where you can do it. Not necessarily in the x-axis. We want to scale it up in the y-axis, right? So let's see, 5. If we move it up a bit, is it good enough? No, I wanted to cover a bit more. Let's say 7. A bit further. 8. Yeah, I think that's good enough. So anything that touches or is inside of this box, well, not anything, but the meteor, it will send an alert message to the robot. The way we can do this is to press this button. There you go. Now this collider has become a trigger. It will not react to other objects in a physical way. It will just be a trigger, invisible, basically. The other thing we want to do is, I'll show you why as well, is to put the trigger under the robot here, under the robot game object. And when we do this, we will attach the trigger to the robot so that it can follow the robot wherever the robot goes. So if we don't do it, I'll show you what happens. Basically, it will stay there, right? Because it's independent on its own. But if we just drag and drop it under the robot here, or on the robot, it will just be shown as under the robot. Now, if we press play, there you go. Now it will be attached to the robot and will follow it everywhere it goes. So right now, this box is being triggered by things, but it's not sending anything. We haven't told it to do anything with those signals. And this is where code comes in. So brace yourself. What we want to do is to create a script, and we pick up these alert messages and we do something with them. In order to create a script, we just need to right click here in the project view and create C# script. I'm not going to create any folder, structure, or anything because this is much simpler and works better for now. So if you create a C# script, we can call this one detect and fire, because we want to detect a meteor and then fire at it. Now you can open the script in any text editor and work on it. I personally am using a software which is also free from Microsoft. It's called Microsoft Visual Studio Code. It's very handy if you want to work with code more. But essentially, it's like any other text editor. This is what you'll see when you first open the script. This is the standard. All scripts are created with this type of information by Unity. What you'll see is a class, basically a group of code here, and you will start coding inside these two brackets. So you have this one, an opening bracket and a closing bracket, and the magic happens here. So a bit of theory here. A class consists of class members, and they can either be descriptive, like variables, for instance, or behavioristic, where you code the behavior. So a variable would be, it will return a value. It would tell you, for instance, the speed, and then you would tell it 5 meters per second or something like that. And a method, which is something like this one here or this one here, the update and the start functions or the start methods, this is where the behavior happens. This is where they change the attributes or the variables. This is where you call upon different types of other methods and make the game run. So these two, start and update, are built in Unity methods that are called automatically. You don't need to do anything. Start is only called in the beginning of the game. So once you start your game, start will be called, and only then. Update is the method that will be called after start, and it will be called every frame. So it will basically keep the loop going. It will make things happen. So we are not going to use those two. I'm going to delete them. Oh, and by the way, these two here, the green ones, they are just comments. So they are not counted as code. They're just ignored. It's just for us to understand what's happening. So let's see what we are going to do. We're going to use another built-in method by Unity, namely the alert system that we have been talking about. Our trigger is actually sending several different messages and different alerts. We'll be using the one called onTriggerStay 2D, because that's the one that will send us updates on every time or all the time that the meteor is inside this this trigger. So if we miss it once, we can detect it again and fire at it. So it's implemented like this: on trigger stay 2D, and then with it we get the other objects collider. So essentially what that means is that when the trigger is sending us this message, it will also send us the other objects collider, basically the meteors collider, as information that we can use to our advantage. So what we want to do is, we don't want to detect anything and everything in the scene, right? We want to do something only if it's a meteor. There are many ways of checking this, but the way we're going to use is to essentially read the tag on the collider. If it says enemy, then we do something. I will show you why enemy in a second. So if other colliders tag equals enemy, then we can, for now, just send the message debug.log. It's a meteor. like that. So what that means is this is a condition here. Only if it's true will we send a debug message in the log, right? So what this says is if the other collider's tag is enemy. And why enemy is because it has been set. So let's save and go back to Unity. Let's see the meteor. If we press on the project, we can find, in our Defender example, we will find meteor here and laser beam. Now, these two things are prefabs. A prefab in Unity is a prefabricated object. Basically, someone has taken an object and already put the art on it, has put components, have tweaked the attributes, has written scripts on attached to it, or whatever it has done, and made it a package ready to be used. You can modify it if you want to, but it can be used as is. This is very handy for us because we can use it right away. Now the meteor here, if you click on it, you will see in the inspector more information. And up here, you'll see the name is meteor, right? But the tag is enemy. We can check the name, but we can also check the enemy. The tag, it's faster and easier this way. So this is why we chose enemy. You can change it to anything else. There are many different tags. You can even write your own tags. But for now, let it be enemy, and we'll detect it that way. Another thing we want to do is if we're going to start using this script that we just wrote, we need to attach it to the actual robot. So we drag it from here and drop it on the robot, not the trigger, but on the robot, and you'll find it here. You can also click on the robot so you can see the inspector, and then drag and drop it here as well. And you will find it here. So let's see if it works. If we press play, there you go. So if we have a look now in the console, so the console view is where all our debug messages are found. We can see that it has indeed detected a meteor. Here you can see that it has detected it 151 times. So we know that it's working. Now the next step is to do something about it. So the next step would be to react. Now that we have detected a meteor, let's shoot at it. We'll be using the bullet prefab here as a blueprint. This is used by our turret or our cannon, but for simplicity's sake, we can use it as well. Remember, anything here in the project is not an actual object inside the game. These are just project files. So the laser beam here is not an actual object, it's just a blueprint. The same thing goes with the meteor here and anything that you see in the project folder or the project view. So this laser beam is going to be referenced. The way we do it is we go back to this script and we say public game object bullet. We can call it bullet, we can call it bullet prefab, right? And what that does is creating a reference. This is a variable that we can set here. So are we on the robot? Here's the robot. Now we can see it here in our, under our script, bullet prefab. There is nothing here. We take the laser beam, drag and drop. Now there is a reference to the blueprint we want to use when we shoot at a meteor. So let's head back to the code. Now what we want to do is, now that we have detected the enemy, we can remove this. We know it's working now. What we want to do is two things. We want to create a bullet in the right place, namely, with the robot. And then we want to fire that bullet upwards, right? So that was our detect and fire script. That's what it's about. Detect it. Once you've detected it, create a bullet, and then fire the bullet upwards towards the meteor. So let's write these down so we don't forget. Create a bullet in the right place, right? The right place being in the robot's position. Let's say this way because that would make it more clear. The robot's position. And the second thing is fire the bullet upwards. So these are our comments, and this is our plan. Let's see how we can do this. Create a new bullet by saying game object. We can call it anything, bullet equals. And then we want to use this bullet prefab here as our blueprint. So the way we do it is we say instantiate. And then we say what we use to instantiate the bullet prefab here. And then we say the position where this is going to be instantiated. So where we're creating the bullet. And we want it to be in, let me show you, in the position of the robot transform dot position. This is as it is. And then it takes the rotation. We just for now say quaternion dot identity, which is basically using the original rotation. Let's see how this works. Let's go back to Unity. Loading, loading, loading. All right, let's see if it works. Now, did we save? I always remember to save. Yes, we did. So let's play and let's see if there are actual bullets being created. Oh, it just, oh, do you see here? Do you see here? Oh, there you go. In the hierarchy. So as you see, it's expanding and then it will shrink. This is due to, let me stop this. There are bullets, they are being created. As you see in the scene view. You can even see these small icons here following it being created, and then they disappear after 2 seconds. This is because of something in the laser beam prefab. Okay, I clicked on it. Let's inspect it. There is a component here called timed self-destruct, and basically what it does, it will self-destroy after 2 seconds. This is, you know, for bullets, so that, you know, they're not in the game forever and take up memory unnecessarily. So this is really, you know, well done. But we have shown that it's working. Now the next step is to fire that bullet. So what it means to fire a bullet is essentially that we're going to add physics. So we'll add a force to the bullet upwards so that it can move. And we'll be doing that by using the rigid body, right? So if we click on the laser beam and inspect it, you'll see a rigid body here, which makes the bullet movable. And what we do is we go back to the code. Now here, we want to access that rigid body and add force to it. This is how we do it. So rigid body, you can call it anything, RB. And then you say the bullet get component rigid body 2D. So now we've grabbed that rigid body from the bullet that we have created, right? Because this bullet that we've created here, this new bullet, is just an instance of that bullet prefab. So it will have everything that the prefab has. And it has certainly a rigid body. We grab that rigid body and we add force to it as such. So rigid RB is just the name that we chose this, so we can work with it like a reference. Dot add force. There you go here. Add force, and it will ask you add force in what direction, for instance. And we wanted to move upwards, so vector to dot up. This is just short to, 0x and 1y, or x equals 0 and y equals 1, so upwards. And force mode, we want to put it, force mode, we want to make it an impulse. The impulse says here, add an instant force impulse to the rigid body using its mass. So let's click here. Let's see how this works now. If we go back, save, go back, loading the script. All right, so let's see how this works. Again, let's make this a bit bigger so we can see it. Let's shoot this down. Let's shoot this down. It's gonna drop. Gonna detect that. Oh, did you see that? A lot of bullets were created, a lot of them. And that's because, if you go back to the script here, and that's because, that on trigger state, as I said, it will be called every frame that a meteor is touching the trigger, right? So every frame, a new bullet will be created. And we can change this by saying, by putting a variable here, for instance, in the if statement, that it's not just an enemy, and we have had a cooldown time. So the way we do this is we create new variables. No, they don't need it. Private float cooldown time equals 0.5 float. So we want it to be half a second. And we also want to create another variable here that will save our time when we created a bullet. So basically saving the timestamp for when we last fired, right? So we can call this time since last fire. You can set it to 0 for now. And how we use them is basically here we say that if colliders tags enemy, and so two ampersands means and our time, which is basically the time since we started the game. It will always keep going, this time. If that one is bigger than the time since last fire plus the cooldown time. So imagine the first frame here. Time, it will start as 0, right? And this one, we have set it initially as 0. And this one is 0.5. So it will say, if it fires right away, it's going to be like, if time is 0, this one is 0. If it's bigger than 0 plus 0.5. So essentially, if this time is bigger than 0.5, then start creating the bullet and fire. If it's not, then wait until it is and then start firing, right? So, you will not do anything. If it's not bigger, then nothing will happen. But when time will start ticking. So after a second, this one, this is 1 second, and this one is still 0. This one is 0.5. So time, which is 1, is bigger than 0.5. Then it will start creating a bullet and fire it. And then what we want to do here now, we have a third step, because we want to create the timestamp, we want to save the timestamp when we actually created a bullet. So it's going to be our new benchmark here. So save timestamp for when the last bullet has been created. So the way we do this is we say time since last fire equals time. So it will just literally save the current time of the game. Let's see how this works now. Save, go back to the Unity project. Oops. There you go. Now, if we play the game, I don't know if you managed to detect it. There you go. Okay, now it works better, doesn't it? Look at that. So one thing we want to fix is the speed of that bullet, right? Because it's moving awfully slowly. We go back to the script and we have a look at it. We see here the force we're adding is essentially just here, shorthand for writing vector 0 and 1. We're just adding the force of 1 unit upwards. So we want this to be bigger. Let's create another variable here called private float bullet speed. All right. So this variable can later on you can actually work with it. You can speed it up or slow it down, you know, depending on, I don't know, power up or a level up or something. So let's say this one is, I don't know, shall we do it 5? And we have to use that variable here. So we do this times bullet speed. Essentially what will happen is up, which is a vector, will be multiplied with a float. So 0 will be multiplied with 5, still 0 on the x-axis, and 1 will be multiplied with 5, so it's going to be 5 units upwards. Let's see how that changes anything. Oh, it's much better now, isn't it? All right, so we have now done the scripting part. Let's see if we can make it a bit more customized. So you know how we have just one blueprint here that we're using? We can create our own one by simply dragging this prefab in the game, right, in the hierarchy. Let's change its name. Now it's an actual game object, so you can find it in the scene somewhere here. Yeah, there it is. It's hiding. There it is. So now it's an instance, so which means that it's an actual game object. We can tweak it and then make our own new game object with it. So let's call it laser beam. No, it's already laser beam. Let's call it robot bullet for the sake of it, right? And let's right click on it here and say unpack prefab completely. What this does is it detaches it from the blueprint, the laser beam blueprint entirely. So now we have like a detached, independent game object, and it's no longer blue, as you see. We can make it blue by dragging, you know, click on it, hold, drag, and drop back into the project. So now you have your own prefab. That's how simple it is to create a prefab. It's blue again, and it is attached to this prefab, not the old laser beam prefab. So now that we have our own robot bullet prefab, we need to change the robot here, the script. We need to change it so that it's using this new robot bullet. So we basically drag and drop it here. Now it's using it. If we click on the robot bullet, we can change it a bit. If you click on the sprite renderer, you can click on the color and let's see, maybe red. I want to make it slightly thinner and a bit shorter, maybe let's like that, the scale. So now we have it here. We can remove this one. We don't need it because let's see. Right, before removing it, click on apply the changes, we apply it to our prefab. Okay, and now we can remove this one because we don't need it. This robot bullet will show the new settings, red, and our scale is 0.2, 0.3. Let's see now how our robot is using this bullet. Oh, there you go, which is, and I'm using the old style bullets here. So it's, oh my God, this is a lifesaver. Yeah. Yeah, so it's working. Awesome. One last thing to add. This will count upwards. The scores will go up. And unless your health is 0, it will, it will go like this infinitely. So we want to have a win screen. This has already been implemented, but it's deactivated right now, and it's easily activated. If you go to the user interface here, you click on it, you will see a script, a component here on it that's called UI script. And you can leave this number of players 1, which is fine. But game type, if you click here and change to, let's say, score. Now you can decide like how much do you want to score until you get the win screen. So you can have 5, you can put 10, you can put 100, as much as you want to. If I put 10 now, for instance, and I press play again, awesome. As soon as we get to 10, and that's it for this time. We made the robot patrol along the whole screen. We made it detect meteors, and we wrote a script to make it react. So it can fire on those meteors upwards. We also created our own prefab and customized it, and we activated the win screen. So we have a complete game loop. So well done on following along all this time. There's a lot to take in, and I hope you got an insight into games programming and that you learned something and you liked this tutorial. And if you managed to create something on your own, please tag us, #ACM Club, one word. Let us know what you created, show us, let us know what you learned. If you have any feedback, just let us know. And please don't forget to hit that like button as well. If you want to know more about our courses, then go to acm.ac.uk and you will find much more information there on everything that we teach. So thank you so much for following along. I'm Huda Mahdi.